Thank you, and thank you for coming. I'm Niels Stampe, and I study technology-based business development in Herning. And I have created I have done a project I call natural language question answering based on unstructured data. I've done it in cooperation with Stibo, as Gast just mentioned, and I've got a lot of help and guidance from Matthias, who's sitting right here, and Esben Klarlund. The background of the project. The reason why I'm interested in this area is because I know that almost 90% of all data in companies are unstructured, meaning that they cannot be put into a tabular form, and only 20% can actually exploit the data to create value. Issue tickets is one example of unstructured text data, and each year Stibo receives thousands of issue tickets, and the numbers are increasing due to the increasing number of customers, and this means that a backlog is building up each month. A part of the issue tickets has been solved before, and the people I have talked to says that it's actually a substantial part that is tickets that has already been resolved. And even though these tickets have a solution, it takes time and resources in research and looking through all the comments in earlier tickets. So the idea was to try to reduce this time in research by making a question answering based on all the earlier tickets. So yeah, to test this thesis, I got access to the online help data and not the issue tickets as such, because there was some legal issues in regards to that because of they contained sensitive text data. But the online help was a substitute, and the solution was built around that data. So the main idea with the project was to build a proof of concept model, and for that it required a list of natural language processing tasks. And yeah, a pipeline is shown here below on the screen, and the first task is extracting the information from the raw data, and then put it into a database, which is a special kind of database that is able to store semantically structured data. And when you have the data stored in such a database, it's possible to ask into it, but not in natural language as we would if we were asking in a question answering machine. It has to be translated to a query language like any other database where you want to extract some information, and then the other way around again. The results from the database has to be converted to a human-like answer. So yeah, that's a lot of natural language processing tasks, and therefore state-of-the-art in that area has been investigated, and mainly one showed to be very interesting and promising. Some of you might know the ChatGPT, and that is actually based on a very large language model called GPT-3, and one of the main proposals from the developers for the GPT-3 was that it is possible to few-shot train it or few-shot learn it. And if you know something about machine learning, normally when you do supervised machine learning, you have a lot of examples to train a machine learning for it to understand a pattern or to find a solution on a new task. With few-shot learning, you can give a few samples, and yeah, that's probably around 10 to 100 samples is enough for it to understand the pattern in the task and find a solution. Some says that this is the greatest opportunity for implementing AI into solutions and businesses. Yeah, here's an example of how you can give 3 examples, and then the last one, it will figure out itself. So the first task I mentioned before is extracting the information from the raw data, and it has to be in this triple format. And to give an example, we can look at some raw data from Wikipedia. This is just about France. And what is key information is this piece of text is that Paris is the capital of France. So you have it in this way where you have 2 nodes and one relation between them. And that's the way the graph database will store the data, with a lot of nodes and even more relations in between them, forming a huge interconnected network. But of course there's more information to be extracted from that piece of information. For example, that Paris is the largest city in France, and Marseille is a major urban area in France. So all the information has to be extracted. Here we also tested the GPT-3, and it showed not that good results actually. So it was decided to go with a more rule-based method that looks at the semantics of a sentence, and for example, if you have an adverb and a noun and in some order, you know what's a node and what's a relation. But there's a huge potential in the GPT-3 still, because maybe we didn't do enough samples. I believe that if more time was invested in testing GPT-3 for this task, it would actually be a better solution. And next up is creating the graph, putting all those triples into the graph. And here we created a function that does this automatically and puts the metadata from the scraped content from online help into the graph as well. And there's a hierarchical structure in the graph. So the documentation is just the online help, and the topics is like just the topics on the left side of the documentation. And each body is a piece of text, and within each piece of text, that could be a sentence or 2, there is a lot of triples within it, and they need to know which piece of text it comes from. That's become relevant later, because now when the graph is populated with all the data, it should be possible to ask into the graph. So here the GPT-3 was actually used because when a question is coming in natural language, GPT-3 is used to extract the key informations from the questions, and the key information is then matched to the graph database, and when it finds a hit, or it probably will find more hits, it looks for one body, a piece of text that contains the most hits, and below that body there's a lot of triplets, and that's the one we want to look for when we will have an answer. So this list of all the words from that body is then used as an answer, and GPT-3 is used again. Yeah. And when testing it, it showed that 5 out of 10 questions were acceptable. And yeah, this means of course there's room for improvements. And as I said, some of the tasks before could definitely be improved or done in another way. And if these improvements were done, just this solution with the online help data, it would actually be relevant for customers to use, because I have learned that some of the questions coming into the Jira system is yeah, kind of stupid questions which don't require the supporters. It could actually it could it could, for example, be questions about the functionalities in Step, which you can just look up in the online help. So that would be relevant, but that would just cut out very little bit of the issues tickets incoming. The huge potential is if the issue tickets data were added as well. This would probably or hopefully result in supporters finding it easier to find the relevant tickets from earlier, or even a hotfix, or get the solution as a human-like answer that they can just answer the customer with. And this would reduce the research time I mentioned before, and the time can then be used at solving the most critical issues that require the professional supporters' attention.